Hi, I am Sri Lakshmi, working as Assistant Professor in CSE Department in Gokaraj Rangaraj Institute of Engineering and Technology. In this video, I am going to explain about logical data design in database management system. Already in my previous video, I have explained about how the conceptual design of the ER model takes place. In this video, I am explaining about logical database design. So, the logical database design, initially I am explaining here about ER to relational database. Like, for example, if we take an employee entity, here we have SSN, Social Security Number, as a primary key, name and lot. So, first we are converting the entity sets into tables like this: SSN, name, lot with attributes or fields. In this we fill the values. Similarly, we write a query like this: create table employees, and SSN is of type character, name is of type character, and lot is of type integer. And in this employee entity, the primary key is Social Security Number. So, the logical database design initially starts with converting the entity sets into table as follows. Next, we will see how to convert the relationship sets to tables. So, for this, we have different types of relationships, as we already seen in the previous videos: one to one, one to many, many to one, many to many. So, in translating a many to many relationship set, attributes of the relation must include keys for each participating entity sets as the foreign keys. This set of attributes forms a super key for the relation. Here we can see works in. Already we have seen in the previous example, works in is the relation. So for this, SSN, DID, SINs are the the different types of fields, and primary key we are giving SSN and DID, and foreign key is referring to the SSN referencing employees. Foreign key is DID, it is referencing department, because DID is present in department and SSN is present in the employees table. So this is how we are converting the relationship set into table. In this slide, I am explaining about how the key constraints also can be represented like this. Each department has at most one manager according to the key constraints of managers. We can see here, this is the employees entity with the SSN, name and lot as the attributes, and department with the DID, DNAME and budget as the attributes, and managers is the relationship here. So we have different types of relationships: one to one, one to many, many to one, many to many, as we are already seeing in our different previous videos also. So how to convert this type of relationships? In the previous slide also we have seen one way. How the mapping of relationship set is done into a table. Here DID is the key now, like this, and in the employees, SSN is the foreign key for the managers table and for the managers relation, and DID is the foreign key in the department table. Like this, we convert our ER diagram with relationship into a table. Another one example also we can see here. Since each department has a unique manager, we could instead combine managers and departments like this, combining managers and departments. Like this also we can do. Department manager, like this. Now there are two types of participation constraints. One is total participation, the other one is partial participation. So here we can see, does each department have a manager? Then in that case, this is a participation constraint. The participation of departments in the managers is said to be total participation. The participation of department here, the total participation is represented by thick line. Every DID value in department's table must appear in a row of the manager's table. That is, in the department table, all the rows must appear in the manager's table. This is called total participation. The other one is partial participation. What is partial participation is, at least one row appears in the managers. Then it is called at least one row appears in that is present in the department appears in the managers relation. That is called partial participation. So the participation of departments is said to be total participation or partial participation. Every DID value in department table must appear in a row of the managers table. That is called the total participation. So in this way we are converting our ER diagram into tables using the logical database design. So even we can convert the easy hierarchies like generalization, specialization also into tables like this. One way. For example, every employee is recorded in the employees. For hourly employees, extra info recorded in the hourly employees like hourly wages, hours worked, SSN. And we must delete hourly employees tuple if referenced by the employee tuple, and if employees tuple is deleted. Queries involving all the employees easy. Those involving just hourly employees require a join. Next, another way of doing this also is like this. Hourly employees, we will keep SSN, name, lot, hourly wages attributes, and each employee must be in one of these two subclasses. This is one way of translating easier hierarchies into tables. Here we can see binary versus ternary relationships. Once again we are referring here how we are converting the ER diagram relationships into tables. This is the bad design and this is the better design. We have seen in the previous video also. Here we are converting the binary relation into ternary relation, because with binary representation we are losing some information. Then we go to the ternary relationship like this. We have three relations: purchase, beneficiary. There are two relations, whereas here only covers is one relation. In this way, by converting the binary relation into ternary relation, we can represent the information in a better fashion. And the binary and ternary relationships can be converted into tables like this also. Create table policies with policy ID, cost, social security number, what are all the primary keys, what are all the foreign keys we can represent here. Similarly, in the previous slide we have seen dependence also one more relation that is represented by table like this. So finally, we are saying that ER model is usually it is very easy to understand and they can be represented easily, clearly. So in this presentation we saw how to convert the ER diagrams into tables or relational schema. Some systems are using ER model for schema design, and some people use ER model as step before creating the relational tables. With this, I am concluding my video. Thank you.